infrastructure objects. It's declarative, so you don't need to program a bit. You just say, I want this component at this place. And here's an example for a simple employee bean. Again, we have the annotation saying this is stateless and remote, telling the AGB server to create all the configuration for running it. And then we have this red line persistent context entity manager, which simply says to the system, I need to have the entity manager variable be filled with a handle to their object in this context that does all the persistency. And the container, when this object is created, fills in a specific entity manager that knows about the current transaction, the current session, and everything else you need to know. It's security settings. And this code doesn't care how it is created. It simply says, I need the current one here. And then it can, in the end, persist an object, the employee object for you. So no dependency on where you run it, how it's configured. Everything else is done in a separate place. And Smalltalk in the enterprise, on the opposite, painful maybe, do it yourself. You have this great language, just write it. Excuse me. This is a bit work if you do it all over again. No standard component model, very little declarativeness. Metaprogram is rarely used. No abstract standard for application infrastructure. You don't have an application model for server applications, a standard one that everybody is following, which would support tool development, framework development. So every project I've seen the last 15 years on the server side looks different from the other one. It's always a new homebrew environment that you build up. So here's an example. James Robertson is not here. Didn't see him. There was an interesting post by Raymond Leon about work on a CISA application he was doing, and he discovered at a certain point he needs thread pooling to limit concurrency. And he said, okay, do it. And he posted about it. And James posted, yes, I have the same thing in my bottom feeder. Well, I could have made it a public, more open resource. I just plugged it in. Kind of, who cares? So it seems to be too simple to do something like a thread pool, which is a crucial enterprise resource, to say, well, let's build it once and for all for everybody. But the point is, not everybody is able to write such infrastructure correctly, efficiently. And so you force, by not having a thread pool for everybody that's written once and great, you force everybody to learn how to do it and to do all the mistakes again. So do it yourself is not a good thing here. But why should we bother? Why shouldn't we say, we've seen just a great CSAT application that talked before. Why should we bother doing these ugly business applications, which is about moving accounts and numbers and customers, which is complete boring code, believe me. It's completely boring code, nothing happy in there. Because Smalltalk is great here. It is great for complex business concept modeling. It's really great for doing the stuff where you need to be agile, need to understand, learn things over time, where Java, being just too tight and too screwed, and to change it quickly. So it really is cheaper here. It's great for rapid domain changes. So that's a reason why, at least in Germany, a lot of banks and insurances had Smalltalk for their product. Because they had product changes every month or every quarter of a year and need to change their code for that. Smalltalk was great for that. Translation between domains, well, a bit of that is in Georg's talk maybe on Wednesday, but I've seen many projects where Smalltalk was part of a larger architecture, where in the end the Smalltalk people were doing all the integration because it was cheaper for everybody. And there's a lot of good Smalltalk code around that we don't want to drop. Okay, what's the proposal here? This is kind of a call for the community, for the vendors is, don't try to reinvent or replace JEE. It doesn't work. This is an elephant you cannot push aside. So the idea is to do the old Smalltalk standby, model and integrate. Model the JEE structures and integrate this model into the JEE world in a JEE server. In the end, Smalltalk will become what I call a shadow container, a shadow system behind a JEE system, invisible to the architecture of the whole system, but doing actually important computations for that. We're going to see pictures later. So the benefit is you are part of the enterprise architecture, so you're not an alien anymore. You're part of the picture. You don't need to justify why you're there. You, in the same time, will have improved server qualities for Smalltalk, which is definitely a good thing. We would simplify the JE interface if we model the JE world on Smalltalk, because then we talk about the same life cycle of things, the same concept, so it's easier to bridge between the worlds. And finally, we would really enable tool vendors, the third-party vendors, to have a market again, which I would love to see. So the to-do list is simple. We need to build first a container system with beans in Smalltalk. That's a list of the first 5 points. Really to be able to do the same positive things with dependency injection, with POJOs on the Smalltalk side. Creating a standard idea of a server application structure based on containers. And the next step is to implement an interface of this structure into the JE world at the bean level. It might look like this. This is a sketch only, so there's no existing software behind it. It's just an idea. The idea is that on the Java side, you've got a proxy bean that represents a Java bean, a Smalltalk bean, and delegates all the computation to the Smalltalk side by a connector architecture. So from the system's view, there is no Smalltalk. It is shadowed. There is simply a Java bean that doesn't compute itself, but it remotes this computation to the Smalltalk side. By this picture, we inherit the transactional controls, the security measures, everything of Java, JEE. We inherit here because the Java bean has all the information. The only thing that we don't inherit is scalability. This is the weak point of this picture. Because if you have a system that needs to run 30,000 users in an hour, and we have maybe for each user 50 calls to our Smalltalk site for a specific computation, for a specific service, we still have to have a stable, robust, and scalable Smalltalk server. So that's the bit that needs to be programmed on the Smalltalk side. Failover security. If you have a messaging system, keeping the message queues alive. All the stuff that's in Gemstone already, I know. Maybe we can use Gemstone and mold it into such a system. So which component should we use? We have many kind of beans in JEE. I would say for the start we're going for session beans, which are coming in two flavors, if you don't know that, in stateless and stateful session beans. Stateless ones are the ones that don't need a session to carry over the state to a next call, so they're used once and then they're used for somebody else. These are for the massive concurrent task. And stateful beans are the ones that keep your state attached to a session for a longer period of time, and that are used, for instance, for workflow tasks. We should concentrate on this. We shouldn't talk about persistency at this time because it adds further complexity, and we shouldn't talk about the other types of bean like messaging beans, singleton beans, and whatever we have. Keep it simple for the first one. And I have here some ideas how it might look on the Smalltalk side so that you don't be afraid that you need to program Java in the end. On the Smalltalk side, we could use pragmas attached to class definitions, which is a new syntax, where we can say, well, this class is actually a bean called hello world. It is stateful. It has the ability to be used remotely or locally. And then for the purpose of the remoting, we need to give some type information to the methods. That's the price to pay if you want to do remoting. If you have better ideas, come to me. Now, then we need containers to make these beans being creatable, findable. And well, they should use dependency injection, they should use meta programming, and they do everything that a Java container also should do. And once we have a simple container notion, we can extend them being for efficiency like threaded or pooling containers. Keeping a certain amount of instances of our beans around for efficiency. We could add transactional behavior, we could add logging behavior, security behavior as a specialization to that. But we just, need to start with containers. And a component deployment description could look like this. Don't read all the details. It's simply the idea you could use your pragmas to configure your beans, or you could write a descriptor that looks a little bit like C-side HTML generation here. So the structured idea, simply saying this is overriding the pragmas. And we're saying this is a deployment descriptor of a container called sample container. So local code for your workspace examples might look like this. We are creating a local context, the environment of our server, and we tell this, please give us the hello world bean. Then we set its name to Barcelona, and then we say transcript show. So that's the easy bit. That's a bit of work to do, so it could be easier. If we are working in a container, we can use injection. We can say, okay, when we start this greet ESUG method, the variable hello should be filled, injected with the hello world bean, and the container is doing all the rest for us, looking it up, creating it, or whatever. So this becomes a very simple piece of code, and we don't have any plumbing anymore. It's completely independent of how the hello world bean is created. And actually, in this example, we could go on and say in the deployment description and change the hello world name to hello world Barcelona. And this could be a different bean implementation that in the end puts out Hola Barcelona, for instance. And we wouldn't see much of this in our code. It's simply the container and the configuration is deciding which bean to inject. So that's the idea of dependency injection in Java, and we are trying to mirror this here. And how do we use this with the integration? There's a few principles. It's very important. The Smalltalk component is never accessed directly. This is the idea of the shadow container. It is represented by a Java bean component on the Java side. So from the point of view of the rest of the system, everything is Java beans. Simply that some of these Java beans don't compute themselves. But they send it through a connector system back to a Smalltalk site where it's computed. The results are sent back. And this is not a simple thing to do because on the Java side we have true multi-threading, operating system level multi-threading. And this needs to be synchronized, of course, with the green threads of Smalltalk, of VisualWorks, for instance. If you look in the documentation of the JNI port or of Java Connect, which are available for various Smalltalk dialects, the matter of synchronization with threading is really painful. And it's not 100% solved yet. So this could be a very interesting thesis to write, maybe. So what are the options? We could use JNI, as I said, which means we could, on the VisualWorks side, use the VM as a DLL and attach the Smalltalk VM to the process space of the Java server and have a direct C-level interconnection. I have no idea if this would work. I never tried it yet. To start a Smalltalk image from a Java server VM. But this would be the most efficient solution, I would say. The other way around, which is usually done today, having a Smalltalk system started up first, and then it starts up all the dependent system, is no option with the Java enterprise world, of course, because it's a server that it's managed by the operations at the customer side. And this one is started and should start everything else it needs. If we are really cheap, we could use web services for a start. Or we could use, if somebody implements it, RMI. Would be great to have that, because that's the standard way of remoting in JEE. So we have many options, and certainly we could start cheaply to test out the architecture and the ideas, and also have the option to give a Smalltalk application that exists today a chance to integrate into a JEE world and live longer. And we could then carry on with a more technical, complicated solution. As you see, this is definitely not a work that one person or one company can do. This is something where the community should agree on if this is a good idea for a server architecture framework and then start working on it in a collaboration way. Otherwise, this is a task too big. So that comes to the end of my talk. Let's repeat a bit. We have a strong success of Java in the server market, and it influenced also the development of the server